Okay, so these are the e-learning science assignments for April 13th through the 17th. So your assignments for science are all going to be in the book for now, and when we run out of book work, we will start doing research projects. So these are going to be the assignments for the entire week. It's pretty standard. So assignment 1 is to read chapter 19, lesson 1, and do number 1 through 3. All 3 problems. Assignment 2 is to read chapter 19, lesson 2, and do number 1 through 3. And then assignment 3 is to complete the chapter 19 review, which is number 1 through 20. So the way I want you guys to do this is you're going to do all 3 assignments before you turn them in. And you're going to turn all 3 in at the same time to this post. And I would like you to attach it all to the same keynote if possible. If you write down your answers on paper, obviously that is fine with me. Just take a picture on your iPad and attach that picture to a keynote and it won't be an issue. Or you can attach those pictures directly to Google Classroom to the assignment. So I'm going to read it to you for those of you who don't want to read it to yourself. Okay, so Chapter 19, Earth, Sun, and Moon. You will discover what Earth, Sun, and Moon are like, what causes the phases of the Moon, how Earth, Moon, Sun relationships relate to days, years, and seasons, and what causes solar and lunar eclipses. What are the effects of the movement of Earth and the Moon? Revolve, orbit, rotate, lunar eclipse, solar eclipse. The vocabulary for this chapter are rotate, revolve, orbit, solar eclipse, and lunar eclipse. What are the characteristics of Earth's sun and moon? The sun provides Earth with the heat and light needed to sustain life. The moon revolves around Earth. The moon's phases are caused by its position relative to Earth and the sun. Our sun. Our sun is a star just like all the stars you see in the night sky. The sun appears larger only because it is much closer to Earth. The sun looks like a ball of fire, but it isn't burning at all. The sun is made of hot gases called plasma. The plasma is so hot that it glows, like the glow of the wire in a light bulb. The inner part of the sun is a dense core with a temperature around 15 million degrees Celsius. Reactions among particles in the core release energy, part of which provide light and heat for Earth. Life couldn't exist on Earth without energy from the sun. Plants use the light energy to produce food for themselves and for other organisms that eat plants. Without the sun's energy, Earth would be a cold, lifeless rock. The sun has no solid surface. Outside the core are swirling layers of plasma. Huge loops of gases, called prominences, extend thousands of kilometers out from the sun. Some prominences are held in place for weeks. Others explode into space. Intense temporary releases of energy from the sun's surface are called solar flares. Energy from these flares sometimes reaches Earth. This energy can cause beautiful light displays called auroras, usually near Earth's poles. Earth's moon. Looking at the moon on a clear night, you might think that it shines like the sun. But the moon has no light of its own. The light you see is the sunlight that reflects off the moon's surface. Unlike the sun, with its swirling hot plasma, the moon is like a giant rock in space. The moon has almost no atmosphere. The moon rotates or spins on its axis while it revolves around the Earth. Revolve means to move on a path around an object. Features of the moon are easy to spot because it is the same side always facing Earth. Why do we only see one side? The time for one rotation and one revolution of the moon are the same as Earth days. Each time the moon revolves around the Earth, it also rotates one time. Phases of the moon. If you look at the moon each night for a month, you'll notice that it seems to change shape. The phases of the moon are the different shapes that the moon seems to have. The shapes change because the size of the lighted part that we can see from Earth changes. Only the half of the moon that faces the sun at any time is lighted. The phases you see depend on the positions of the moon, Earth, and the sun. A new moon is the dark phase of the moon. During a new moon, the side of the moon facing Earth is not lighted. On nights just after a new moon, the moon begins to wax. Waxing means gradually growing larger. The moon is waxing when more of its lighted part can be seen each night. A full moon is the completely lighted phase of the moon. On nights after a full moon, the moon begins to wane. Waning means gradually becoming smaller. The moon is waning when less of its lighted part can be seen each night. The moon continues to wane until you once again see a new moon, and the cycle continues. A complete cycle of moon phases occurs about every 29 and a half days. I'm going to read the top on all the moon phases. Waxing crescent. As the moon begins to wax, a crescent of light begins to show on the side. First quarter. As the moon continues to wax, you can see half of its lighted side. Waxing gibbous. The moon continues to wax. The shape of the moon we see is now called gibbous. Full moon. About 2 weeks after a new moon, the moon appears fully lighted. It has completed half of its path around the Earth. Waning gibbous. The moon begins to wane. The gibbous shape is known on the left side of the moon. Is now on the left side of the moon. Third quarter. The moon has now traveled about 3/4 of its path around the Earth. Its lighted half you see is now on the side opposite of the first quarter. Waning crescent. The moon is now waning. Each night the lighted portion grows smaller until a thin crescent of light is visible. Learning about the moon. Although the moon has been known to humans since prehistoric times, the first visit to the moon by a spacecraft didn't happen until 1957. That year, the unmanned Soviet spacecraft Luna 2 landed on the surface of the moon. 10 years later, Apollo 11, astronauts Edwin Buzz Aldrin and Neil Armstrong were the first humans to land on the moon. Their landing was followed by 5 more moon landings, the last in 1972. Scientists study information they collected on those journeys to learn about the moon, Earth, and the entire solar system. Because the moon has almost no atmosphere, its surface remains undisturbed. Scientists can study the craters and other features of the moon's surface to help determine the age of the moon and of Earth. Okay, so there's only 2 problems, so obviously Miss Wernicke got it wrong for assignment 1. You're just doing number 1 and number 2. So, explain why the same side of the moon always faces Earth. Use the terms rotate and revolve. You can find that in the top section on page 536 under Earth's moon. I want you to reread it and find the answer. And then number 2, space exploration began on October 4th, 1957. When the Soviet Union launched Sputnik 1, find out what other spacecraft were launched between that date and the last mission to the moon in 1972. Draw a timeline of those events. So you're going to need to do some research. I do want you to do number 2. You can use Keynote to make your timeline. Alright, on to lesson 2. What are the effects of the movements of Earth and the moon? Days, years, and seasons are caused by Earth's rotation, revolution, and tilt on its axis. The changing positions of the sun, moon, and Earth can cause solar and lunar eclipses. Earth on its axis. Think about a time thousands of years ago before telescopes had been invented and before astronauts had ever traveled into space. What did people think of Earth and its sun? If you look at the daytime sky, the sun rises in the east and sets in the west. People naturally thought the sun was moving around Earth. We now know that the sun is in the center of our solar system and that Earth and other planets revolve around the sun. Earth also rotates on its axis, an imaginary line between its poles. A day is the total time for a planet to make one complete rotation. The sun seems to revolve around Earth because of Earth's rotation. If you wake up early in the morning, you might see the sun just beginning to rise above the eastern horizon. The sun always seems to rise in the east because Earth spins from west to east. Because you spin along with Earth, the sun is first visible in the east. You experience daytime as long as the sun is visible from your location on Earth. Daytime ends when Earth has turned enough that the sun seems to set in the west. Nighttime is when the sun is no longer visible to you. When you wake up on a winter morning, it may still be dark outside. If you wake up at the same time in summer, it may have been light outside for hours. The number of hours of daylight changes throughout the year. Notice on the globe how Earth is tilted on its axis. One half of Earth is usually tilted slightly toward the sun. That side has more daylight hours and fewer nighttime hours. The other half of Earth has fewer daylight hours and more nighttime hours. The tilt of Earth's axis has an even greater effect at the poles. When the northern part of Earth is tilted toward the sun never fully sets at the North Pole. The same is true at the South Pole when it is tilted toward the sun. Daylight and darkness at the poles each last 6 months. You may have noticed that the moon is sometimes visible during the day. The moon can be seen whenever it is on your side of Earth. This is sometimes during daytime and sometimes during nighttime. Comparing sizes. If you stand on the top of a mountain or on an ocean shore and look toward the horizon, you realize that Earth is unbelievably large. Compared to the sun, however, Earth is just a dot in space. The sun is more than 200 times wider than Earth. If the sun were hollow, more than 1 million Earths could fit inside. The mass of the sun is about 330,000 times the mass of Earth. Its gravitational pull is almost 30 times greater than on Earth's surface. The difference between Earth and the moon are not as great. Earth is about 4 times wider than the moon, and about 50 moons could fit inside a hollow Earth. Earth's mass is about 80 times the mass of the moon. The gravitational pull on Earth's surface is about 6 times stronger than on the moon's surface. That's why an object that weighs 60 newtons on Earth would only weigh 10 newtons on the moon. In the evening, the sun appears to sink below the western horizon. At midnight, the side of Earth opposite to you experiences the noon sun. As the sun rises into the eastern sky, sunlight begins to warm the Earth. Heat from the sun is most intense around noon when the sun is of its highest point. Earth's orbit and seasons. Like all objects in space, Earth tends to move in a straight line. The force of the sun's gravity, however, pulls Earth toward the sun out of a straight line path. As a result, Earth revolves around the sun. An orbit is the path of an object that revolves around another object. Earth's orbit around the sun is an ellipse, a slightly flattened circle. A year, about 365 days, is the total amount of time Earth takes to make one orbit around the sun. Because Earth's orbit is an ellipse, it is sometimes slightly closer to the sun than at other times. People often think summer is when Earth is closer to the sun, but is this really true? To answer this question, think about standing close to a heater so that your face feels warm. If you step just a few centimeters back, the warmth you feel doesn't change. If you turn around, however, your face no longer feels warm. The tilt and the seasons. In a similar way, the slight difference in the distance to the sun as Earth moves around its orbit has no effect on seasons. In fact, Earth is slightly closer to the sun when the northern half has winter. Earth's tilt on its axis causes seasons. The sun warms the side of Earth that tilts toward it more than it does the side tilted away. When the North Pole tilts toward the sun, the northern half of Earth has summer and the southern half has winter. When the South Pole tilts toward the sun, the seasons are reversed, in spring and in fall. Neither pole tilts toward the sun. Both the northern and southern halves of Earth have mild temperatures. The tilt of Earth's axis affects how directly the sun shines on Earth as it travels in its orbit. When the North Pole tilts away from the sun's light is very spread out here. The northern hemisphere receives the least amount of energy at this time of year. Temperatures drop and winter sets in. The sun's light strikes the Earth more directly south of the equator. The light is concentrated, not spread out. Concentrated energy gives this region warm summer weather. In summer, the sun's rays point almost directly toward you at noon. The direct sunlight makes the days very warm. The shadow you make is very small. As each day passes, the sun's rays strike you at a greater and greater angle. We say the sun is lower in the sky. With less direct rays from the sun, the days are not as warm. Your noontime shadow gets longer and longer. You have winter when the part of Earth where you live is tilted away from the sun. At noon, the angle of the sun's rays is large, and you make a long shadow. A year can be defined as the time between the days where your shadow is at its shortest. Late June, the north end of Earth's axis is tilted toward the sun. It is summer in the northern hemisphere. The southern hemisphere is having winter. Late March, neither hemisphere is pointed toward the sun. The northern hemisphere is experiencing spring. It is fall in the southern hemisphere. Late December, the south end of the Earth's axis is pointed toward the sun. It is winter in the northern hemisphere and summer in the southern hemisphere. Late September, neither hemisphere is pointed toward the sun. The northern hemisphere is experiencing fall. It is spring in the southern hemisphere. Solar eclipses. If you draw a picture of Earth's orbit around the sun on a piece of paper, you can't draw the moon's true orbit around Earth on the same paper. The moon's orbit is tilted slightly at an angle from Earth's orbit. You can see the effect of this during a new moon. If the new moon occurs in daytime, you can see the sun. The moon is a little above or below the sun because of the tilt of its orbit. Sometimes, however, the orbit of the moon crosses exactly between the sun and the Earth. The moon eclipses or covers the sun. A solar eclipse occurs when the moon blocks the light of the sun. The moon makes two types of shadows on Earth during an eclipse. The umbra is the darker inner part of an eclipse shadow. The penumbra is the lighter outer part of an eclipse shadow. You can see these on the picture at the right. Even though solar eclipses occur several times a year, each place on Earth only experiences one every few hundred years. During a solar eclipse, a place on Earth may experience a total or partial eclipse of the sun or no eclipse at all. A total eclipse is when the umbra passes over an area. For several minutes, the sun is completely blocked from view. The sky darkens and the stars are visible in daytime. Because the moon's shadow is so small, only a small part of Earth experiences a total eclipse. Nearby areas that are in the penumbra experience a partial eclipse. A partial eclipse can also occur when the umbra completely misses Earth and only the penumbra passes over. It's important to remember that you should never look directly at the sun. A good way to view an eclipse is by using two pieces of white cardboard. Place one piece of cardboard on the ground. Place a pinhole in the center of the other piece. Point the pinhole at the sun so that you see a round image on the other cardboard. The round spot of light you see on the paper is a pinhole image of the sun. Lunar eclipses. A different kind of eclipse can occur during a full moon. When Earth is between the sun and the moon, a lunar eclipse happens when the moon passes through Earth's shadow. You can safely watch a lunar eclipse. During a total eclipse, you might see the moon passing through Earth's shadow for almost 2 hours. The time is shorter for partial eclipses. Unlike a solar eclipse, a lunar eclipse can be seen by most parts of Earth where it is nighttime. Lunar and solar eclipses occur about twice a year, but because lunar eclipses are visible from half the Earth, you are much more likely to see one. Alright, so this lesson checkpoint, number 1, 2, and 3. Number 1, what are 2 ways an area can experience a partial eclipse? We just read about that, so you're going to have to go back and reread if you missed it. Number 2, write details to support this main idea. During a solar eclipse, the moon blocks the light of the sun. So imagine this, our main idea and key detail chart, where that statement, during a solar eclipse, the moon blocks the light of the sun, is in the circle in the middle, and then I want you to find 4 or 5 key details to support that. And then number 3, during a total lunar eclipse, the moon appears slightly red. Research to find the cause of this effect and write a paragraph explaining it. So you're going to need to do research on your iPad, on your phone, whatever electronic device you have to figure that out. Good luck. And then your last assignment is the review, number 1 through 20. If there are any in there that's like go outside and look at this, don't do that. Just skip those ones, okay? All right, I hope you guys have a good week doing science. Email me if you have any questions.